Okay, the system, first system is y equals 2x plus 1, y equals negative x plus 2. To solve that system, we're going to subtract the equations. To subtract the equations, we're going to multiply the second equation by negative 1, and then we're going to add the results. Okay, so negative 1 times y is negative y, negative 1 times negative x plus 2 is the negative of the quantity, negative x plus 2. So we have y equals 2x plus 1, and simplifying this, we get negative y equals what? Negative x is x, negative of 2 is negative 2. So we get negative y equals x minus 2. And now we've got the first equation and the negative of the second. We're going to add them. So y and negative y gives us 0. 2x minus x, 2x plus x, gives us 3x. And 1 added to negative 2 gives us negative 1. We get 0 equals 3x minus 1. And that rearranges to 3x equals 1, x equals 1/3. And the details of the algebra, I didn't go through in class, but I'll write it out real quickly. You got 0 equals 3x minus 1. We add 1 to both sides, so we get 1 equals 3x, which is the same as 3x equals 1. And then we divide both sides by 3 to get x equals 1 over 3. Okay, so instantly you should be able to get from here to here. Now somebody plays that, well, it looks like it ought to be negative 1/3. Yeah, it does. It does. That's why you go through the steps and verify your solution. If you put 1/3 in for x, you get 3 times 1/3. That's 1. 1 minus 1 is 0. X equals 1/3 satisfies it. X equals negative 1/3 wouldn't. So be sure you're always checking your solutions. Make sure that you're certain of this solution. In any case, now we've got x equals 1/3, so we can plug that in to either equation. And when we do, the x's are going to go out of the equation. We got y equals 2x plus 1. We plug in 1/3 for x, we get y equals 2 times 1/3 plus 1. And that's y equals 5/3, which is 1 2/3. Okay, now how does this x and y compare with the estimate we made up here? Well, we got x equals 1/3. Our estimate was 1/2. Okay, well, that's 1/3 isn't far from 1/2. 1/2 was a good estimate. Okay, we got y equals 5/3, which is 1 2/3. We estimated 3/2, which is 1 1/2. 1 1/2 is close to 1 2/3, so we had a good estimate. It just wasn't completely accurate, and we had to use the algebra to get the accurate result. This means that if we drew our graphs with complete accuracy, they would intersect at 1/3, 5/3, as opposed to 1/2, 3/2. This is close, good estimate, this is accurate.